Hello students, welcome to Saurabh Sir's classes. Today we are going to solve CAT 2017 question paper. In our last videos we have solved questions up till 93. So now we are going to start with question number 94. So question 94 says if A, B, C, D are integers such that A plus B plus C plus D equal to 30. Okay, so here we are talking about four different integers whose sum are 30, then the minimum possible value of a minus b whole square plus a minus c whole square plus a minus d whole square is. Okay, so we need to find the minimum possible value of this equation when a plus b plus c plus d is equal to 30. So for this minimum possible value we need to check our this MCQs, the options we have. So options are 3, 0, 1 and 2. So the least number is 0. So let's check if 0 is possible or not. So for being 0, this equation we have a minus b whole square plus a minus c whole square plus a minus d whole square. So for this equation to be 0, we need 0 from here, 0 from here and 0 from here, because we cannot have any negative values, because we have square of all the terms and square of every term makes every term positive. So we can have possibly only 0 in all three brackets to get total 0. So for being 0, we need this condition, which is a equal to b equal to c equal to d, because here it should be a equal to b, here it should be a equal to c, here it should be a equal to d. So for this we need a equal to b equal to c equal to d. So now let's check from this equation what do we get. A plus b plus c plus d equal to 30. So for all the same we will get 4a equal to 30, where a will be equal to 7.5. But here we have been said that a, b, c, d are integers. Here a is equal to 7.5, which is not an integer. Therefore this condition is not applied. Therefore we cannot get the least value to be 0. Hence our option number B is not true. So now let's check the second least, which is option number C. So for option C to be true, we need this equation as, let us write the equation again, a minus b whole square plus a minus c whole square plus a minus d whole square. So again, as I said, that we cannot get any negative value because of the squares. So for being 1, we need here 0 0 1 or 0 1 0 or 1 0 0. So for this three at least three integers, here we have four integers. For this at least three integers should have same value, and the fourth integer should have a value which is one more or one less. So for that, let a b c be equal, let a equal to b equal to c, and let d equal to a plus 1. So d can be a plus 1 also, d can be a minus 1 also. You can consider anything and proceed. So for this condition, here we will have a plus b plus c plus d equal to 30. So let's check, is it possible? So a equal to b equal to c, so this will be 3a, plus here we have a plus 1, so this will be a plus 1, which is equal to 30. So solving this we get 4a equal to 29, which is equal to a equal to 29 by 4. So this is also not an integer, so our a is not coming as an integer, which is violence to our question. So option number C is also not correct, where our this assumption was wrong. So option C also gets cancelled out. So now let's check with option number D, which is 2. So let's check if 2 is possible or not. So here we will have 2. So let us write the equation a minus b whole square plus a minus c whole square plus a minus d whole square. So for 2, this can be 0 1 1 or 1 1 0 or 1 0 1. So for this condition we need only two integers to be same, and the other two should also be same, so that we will get our sum to be 30. So let a equal to b and let c equal to d, where a is equal to let c equal to a plus 1. Our difference should also be 1, so that we will get let a minus b should also be 1, so the difference should be 1 between them. So here we will have 0 because we have considered a equal to b. Here we will have difference equal to 1, that is a minus c equal to 1. Therefore a equal to b and c equal to d, and we have c equal to a plus 1. Therefore we will have d equal to a plus 1, which is also equal to b plus 1, which is also equal to b plus 1. So let us check whether these conditions sum up to 30. So here we have a plus b plus c plus d equal to 30. So a and b are equal, so this will be 2a, plus c and d are equal, so this will be 2c equal to 30. Here we have c equal to a plus 1, so let's put that here. We have 2a plus c equal to a plus 1 equal to 30. Here we will have 2a plus 2a plus 2 equal to 30. Here we have 4a equal to 28. Therefore a is equal to 28 by 4, which is equal to 7. So as you can see here we have got a equal to 7, so which is an integer, and we have a equal to b, therefore this will be 7, and our c equal to d equal to a plus 1, which is 7 plus 1 equal to 8. So our all the four integers are a comma b comma c comma d equal to 7 comma 7 comma 8 comma 8, which sum up to 30, and we have got this condition. So our least possible number here is 2. Therefore our correct answer to this question is option number D. So we have got the correct answer here. So now let's move on to our next question, that is question number 95. So question 95 says, let A, B, C, D, E, F, G, H and J, K be 5 diameters of a circle with center O. Okay, so here we are talking about a circle. So let us draw the circle here. So here we have a circle with our center is O. So let this be center O, and we have 5 diameters. So let us draw these 5 diameters of the circle. So here is our first diameter. Here is our second diameter. Oops, it's a line, not a diameter. Okay, so let us draw the second diameter, where it will be like this. Here we will have our third diameter, which will be something like this. Here we have our fourth diameter, which will be like this, and our fifth diameter, that is like this. So here we have 5 diameters that is given in our question. So now let's name them. Okay, so our first diameter is AB, second is CD, third is EF, fourth is GH, and the fifth is JK, and our center here is O. So using this, let's see in how many ways can 3 points be chosen out of A, B, C, D, E, F, J, K and O so as to form a triangle. Okay, so we have here total 11 points, and we need to form triangles with these 11 points, taking 3 at a time. So we need to tell how many number of triangles can we make with these 11 points. So first let us eliminate point O. Let us not take point O, and let us take these 10 points, which are A, B, C, D, E, F, G, H, J and K. We have 10 points of these 5 diameters. So taking these 10 points, we can take any 3 out of them and form a triangle. So taking 3 out of 10 can be done in 10C3 ways. So this is 10C3, which is 10 factorial by 3 factorial into 7 factorial. We have general formula PCQ is equal to P factorial by Q factorial into P minus Q factorial. So this is 10 factorial is 10 into 8 into here we have 9 into 8 into 7 factorial divided by 3 factorial is 3 into 2 into 1 into 7 factorial. So 7 factorial gets cancelled out. Here we have 3 3's are 9 and 2 4's are 8. So this will be 120. So here we have 120 ways of drawing triangles when we are leaving the center. So now let's consider the center and assume and find out how many triangles can we make. So when we take the center, we need 2 more points. So let our first point be any point such as A. So here is our one center and here is our one A. So in how many ways can we take the third point? So the third point can be any point out of these remaining 9 points on the circle, but we can't take this point B, because if we take points A, O and B, we will get a straight line and not a triangle. So we can't take points A and we can't take point B. So the remaining we have total 8 points. So for every letter, that is A, B, C, D, E, F, G, H, J, K, we have 10 points on the circle. For every point we can take 8 different points for circle. So we have 10 points on the circle, and for each we will take 8 points and we can form triangles. But if we take AOC, so we get a triangle AOC, and when we fix our points O and C, we can't take A because we have already taken A in our triangle AOC, so we can't take A in our triangle OCA. So we need to divide this by 2 so that we eliminate the repetition of the triangles. So from this we will get 40 ways. So here we have 40 ways when we consider this center of the circle, and here we have total 120 ways when we don't consider the center of the circle. So adding both of them, we will get total number of triangles. Number of triangles will be 120 leaving the center, and 40 when we consider the center will be equal to 160 ways we can make the triangle. So 160 is our answer. Now let's check the options. Option number C matches with our answer, hence option C is the correct answer to this question. So I will like to end this video here. You will find solutions to the further questions in our next videos.